Connecting to SQL databases. Hello everybody, this is Ben Finkel, and in this nugget we want to take a look at how you can use the MySQL.connector library provided by the MySQL folks themselves in order to connect to a back-end MySQL database for persistent data storage. The further along you get in your Python development, the more you're going to want to connect to a database of some kind for persistent data storage. Whether it's sharing data between two different users or even sharing data from two different sessions for an individual user, you're going to want to get that data out of memory and onto a disk somewhere so that it can be shared between each session, and databases are a fairly common repository for that sort of thing. For this nugget, we're going to take a look at connecting to one of the most popular open source SQL databases out there called MySQL. MySQL is easily available on the MySQL webpage. You can download it, install it on any different operating system. It's widely available, super popular. It has millions of users all over the globe. It's really easy to use, and it's really easy to connect to Python. It actually has a native Python connector built in that we're going to use here. Now you can go ahead and install MySQL locally on your desktop if you'd like. It's not all that hard, and the instructions are available on the website. Or if you have access to a MySQL farm somewhere that you can connect to an instance of it, you can plan to connect up to that instance of it. But for the purposes of this nugget, we're going to use one of the many cloud provider options out there that give us access to MySQL instances very easily and very cheap. In this case, we're going to use the Google Cloud Platform, specifically their Cloud SQL product. And that's just going to allow us to create virtual MySQL instances out in the Google network, out on Google's platform, so that we can quickly and easily connect up to it from our local Python application. To begin with, let's get the MySQL connector installed on our local desktop. And that's very easy to do. You're just going to go out to the MySQL connector download page out here, Downloads Connector Python. And you're going to scroll down to the download section, choose the right platform, in my case it's Mac OS X, and click download, and this is just going to download a DMG file for me. You will have to sign up for a free Oracle web account. It might take a few minutes if you don't already have one. But once you've signed up and signed in, you just get an easy link to download your file. Go ahead and download that. It's very small and doesn't take long to download at all. And then I can go ahead and open it up. Get my package installer on screen here and install my MySQL connector into my system. So this is going to install MySQL into my Python library for me. I'm just going to walk through the wizard, leaving all the defaults. And once it's complete, it'll tell me it was successful, and I can drop right out of here and unmount or eject my DMG file. Now that'll handle the client side of things, but we also need to worry about the server side. We've got to get our SQL database set up. And to do that, you're going to go to the developers console from Google. That's at console.developers.google.com. You need to create a developer account if you don't already have one. It's easy to do, and you can hook it up to any Google account that you might have. You also need to create a new project inside of this console. The name of the project doesn't really matter, just set up a project for yourself. And then lastly, you'll have to enable billing on that project. Now it is true that to enable billing you have to put in some credit card number. And that's because Google Cloud SQL will accrue some basic charges, even in minimal usage of it. But if you're new to Google Developers Console, you can sign up for a starter pack credit, and that'll get you some money to play around with so you don't have to actually worry about accruing charges. It's sort of like a gift card for the Developers Console. So once you've done all of that, then you can simply scroll down on the left-hand navigation pane here to Storage Cloud SQL and click Create an Instance. And we can give our instance ID anything we'd like. I'll call it my new instance. Choose the region. I'm going to choose United States. And choose the tier. This affects the size of the database and ultimately what you're charged for it. I'm going to choose D0, the basic, cheapest, smallest tier, because I just want to show this off a little bit. Click Save, and a few moments later, my database instance is created. I can tell that my instance is up and running and accessible because its status is now set to runnable as opposed to being created, which is where it was while it was spinning up. Now the second thing I need to do is, by default, this Cloud SQL instance does not get an external IP. It needs an IP address that can be seen outside of the Google Cloud Platform. So I'm going to select my instance and choose Access Control tab here. And having done that, I'm simply going to request an IP address right at the top of my Access Control options. Once I've done that, the IP address gets assigned or reserved to my instance. Now you'll notice that it tells me I have not authorized any networks to connect yet, so I still can't get to this IP address. So the IP address exists. I also need to whitelist some access to this console, and I'm going to do that with my direct IP address from my desktop. So what is my IP? Looks like it is 72.231. I'm going to grab that IP address and just drop it in here and click add, and now my instance is visible from the outside world. I'm also going to set a root password because I want to access my database via the root password, and I'll just call it ROOT-PWD. Make sure I type that in right. Root PWD. Oop, too many O's. Yeah, see, I would have been very confused. Click set, and now I've got a root password and an accessible IP address on my instance. Okay, we're all set with our servers now. Let's take a look at the code and see how we're going to write some connections to this database. So I've got my first piece of MySQL connector code up on screen here. It looks a little bit complicated, but it's not too complicated actually once we get into it. To begin with, I have to import the MySQL.connector. I'm also importing the error codes for MySQL.connector, and that's because you'll notice that I'm going to do a lot of try and except statements wrapped around my database statements. You really want to do this. You want to make sure that you've got good error handling whenever you're working with any database technology, MySQL or otherwise. It's very important to make sure that you're gracefully handling the many myriad of problems that can come up. Then, in order to create the connection to my instance, I'm calling this CONN equals MySQL.connector.connect. And that's all I need to do. This is going to create a MySQL connection to this database. Notice I'm using my user root and my password, root-pwd, that I set up, as well as my host I've set to the IP address that was reserved for my database. Remember that back here on my console? Right here, IP address 173.194. Well, that's the IP address that I'm going to use here to connect with. Once I've connected successfully, I also get a handle to a cursor object, which is exposed by the MySQL library. So my first statement here is a cursor.execute, and I just pass in straight MySQL code as a string right into this cursor.execute command. In this case, create database employees with a default character set of UTF-8. All I'm doing here is I'm creating an employees database. I got to have a database inside of my instance before I can create any tables or insert any data. Also notice that I'm trapping my errors down here with my except statement, and the one that I check for specifically is if the database already exists. If it does, I'm going to print out an error log saying, hey, this database already exists. I'm going to continue with the rest of the code. After that, once the database is created or we verified that it already exists, we set our connection.database equal to that employee's database. So now my cursor is going to execute against the employee's database. Down below here, I call a create table statement, simply creating an employees table with a few basic fields in it: employee number, first name, last name, and hire date. Setting my engine equal to InnoDB, that's the default engine for Cloud SQL. And then I also trap errors there just to make sure that the table doesn't already exist. And if it does, I print out an error message. The very last thing that I do inside of this code is call a connection.close command. I want to make sure that if I get to the end cleanly and successfully, I close my connection to the database. Alright, so let's execute this code, see it in action. I'm just going to call Python mysql1.py. And it takes a few seconds, drops me right back to the console. How do I know it ran? Well, because of my good error checking, I can actually just execute it one more time, and you'll see I get my two diagnostic output messages this time. Database already exists, and employees table already exists. So I successfully connected to my MySQL database, created an employees database, and added an employees table into that employees database. Now let's insert some data into it. Inserting data using the MySQL connector is very similar to what we just did. I've added one parameter onto my connector.connect statement, and that is database equals employees. Since I've already created the database, and I'm assuming in this code sample that it exists already, I'm just connecting to it right away. Then, down here in my first try statement, I call 3 straight SQL insert statements. I'm just passing the SQL into the cursor.execute command. I'm inserting 3 employees. You can see their last name, their first name, and their hire date. And then, very importantly, I'm calling this connection.commit. Until I call that, all these things are going to be updated in memory inside of my cursor, inside of my connection in Python, but they're not going to be updated in the actual database itself. The database interaction is transactional. That means I set up my transaction, and assuming it executes without a problem, I can then commit it to the database and be assured that it's a good, clean commit for my database. Then, once I've done that, we also, hey, we want to check, make sure this data got in right. So below here, I actually call a simple select statement. And this time, when I call cur.execute, I'm passing in a where clause, so I should only get employees where the hire date is after 2000. You'll notice that I have to actually iterate through the cursor object down here now with a for statement. My cursor is a pointer to my results set. So I have to iterate through, and I can print out each of first name, last name, and hire date, the results from my cursor.execute query. Let's see it in action. Come here and say Python mysql2.py. And all you're going to see happen is my two results returned, Ben Finkel and Alice Smith. So I inserted all three employees right here, and then my query brought back anyone with a hire date after 2000, January 1st. Well, that left off Bob Jones here. So only Ben Finkel and Alice Smith were returned. So you can see very quickly and easily we got some data inserted into our database, and we were able to query it. And you know it's working, right? If I run this again, what's going to happen? Well, I'm going to reinsert 3 more values, which means my query now this time is going to return 4 values. And then 6 values, and so on and so forth. So that data is being written out to the MySQL instance here in the Google Cloud, which is really actually pretty cool. It was super easy and fast to do, and it required very little work on our part. Now, this isn't a great way to work with SQL. You're probably going to want to download an ORM library of some kind so that you don't have to write straight SQL strings inside of your code. Go ahead and take a look at the Python PI package index, read up on some forums, see what's out there and available for interacting with MySQL. There's many cleaner ways to do it. You can find one that's going to work for your project. But at a very basic level, I think this was pretty easy and fast to do. And that concludes this nugget on connecting to SQL databases with Python. We saw how you could use the MySQL connector library to connect to really any MySQL backend, although we set up a Google Cloud Platform Cloud SQL instance in order to store and query our data from. I hope this has been informative for you, and I'd like to thank you for viewing.